Alright, and it is recording. Okay, so today we're gonna do CSP2. We're gonna start off with chapter 10, which is the last chapter, Boolean logic. The reason I want to start off with chapter 10 is because it relates to chapter 1 a lot, and you guys will see in a while why I said we should start from chapter 10. Then we're gonna move on to chapter 9, which is databases. The reason why I want to put that next is because it's completely unrelated to everything else. So the most correlation in that is just data type. So it'll give us a basic understanding for chapter 7, which is what we're going to do next, leaving chapter 8 for last. So let's just, okay. Now, when we talk about, when we talk about computers, okay, so I think, yeah, my Wi-Fi killed itself. Okay, so I was saying that we're gonna do chapter 10, we're gonna do chapter 9, and then we're gonna move on to chapter 7. So when we talk about computers, obviously computers don't read, write, and do all of that stuff on their own. So we know that computers, they work on arithmetic calculations and multiplication, division, all of that stuff. So that's where Boolean logic comes into play. Boolean logic, it utilizes different gates, okay, like the AND gate, the OR gate, the NOT gate, all of these to manipulate bits, right? So we're just going to cover a bit of each one of them, and we're going to just have an overview of them. We're going to see how logic circuits work, and we're going to start off with chapter 10. Let me just pull out some notes, some screenshots, sorry, and we're going to start, where the hell is it? Okay, okay, I'll just pull out C notes, I guess. Okay, CAIE, O level, IGCSE, where is it? Computer science, practical, Boolean logic. Okay, so when we talk about Boolean logic, like I said, it's a way to manipulate bits, okay? So it's a way, you know, that everything, it depends on a bunch of zeros and ones. So what Boolean logic is, it's basically just a way to manipulate these zeros and ones. So let me just create a new note, and let's name this chapter 10, Boolean logic. So when we talk about Boolean logic, there's 6 different gates that you need to know. The first gate is called the NOT gate, and we're going to go over each one of these. The second gate is called the OR gate. The third gate is called the AND gate. These are the 3 basic gates that you should know what they do. So the NOT gate is basically used to flip switches. So if you have a light turned on in your room and you turn it off, you can theoretically say that you made the light go through a NOT gate, because you just turned a 0 or a 1 into a 0, right? So you just turned an on signal into an off signal. That's what the NOT gate does. It basically converts an on signal to an off signal, or an off signal to an on signal, right? That's what the duty of a NOT gate is. Now, one thing that we're going to notice a lot is called truth tables. Now, I told you we mainly use these to manipulate bits, right? In A levels, in AS level, if any one of you takes computer science, you'll learn something called bit manipulation. So there's something that we call, let me just zoom this in for you guys as well. It's called truth tables. What truth tables are is they're basically a method to represent all of these different types of bit manipulations, right? So we usually have inputs and then we have outputs. So if we look at how a NOT gate looks like, right? So let me just fetch an image of a NOT gate. So let me just copy this and paste it over here. So you can see that in a NOT gate, you can see that there's an input on the left side, and then that goes through, and then there's an output on the right side. So for a NOT gate, there's only one input, which I labeled as A, and then there's only one output, which I labeled at X. Now there's only two possibilities of A. The first possibility is that A is equal to 0, and the second possibility is that A is equal to 1, right? So I told you guys, NOT gate, pretty simple, just used to flip the bit. So if it's a 0, it becomes a 1, and if it's a 1, it becomes a 0. So if you plug in a 0 into a NOT gate, that'll become an output of 1, or if you plug in a 1 into a NOT gate, that'll give you an output of 0. That's the first thing. That's the first gate. You should know what the NOT gate is. It's pretty simple. Then you have the OR gate. Now, the OR gate is okay. Let me copy an image of the OR gate as well. So the OR gate, it looks something like this. So it's kind of like it kind of like has this curve at the start, and unlike a NOT gate, it takes in two inputs. Now I'm gonna teach you guys a really easy way to measure all of these inputs. So let me just remove this table right over here, and let me just tell you guys how these inputs look like. So in the exam, you'll be given something like A, B, A, B, and X, right? And maybe you'll be given some working space in between. So that's what a truth table looks like. So in the case of two inputs, you have the possibility of 0, 0, 1, 1, 0, 1, 0, 1. So you don't really need to memorize this notation, right? It's not necessary. So in the case of an OR gate, you have a 0, 0, a 0, 1, a 1, 0, and a 1, 1, right? So in an OR gate, you can think of an OR gate as a plus symbol, all right? We also signify an OR gate using a plus, but we'll get to that in a while. So an OR gate, you can think of it as a plus. So what's 0 plus 0? That's just equal to 0. What's 0 plus 1? That's just equal to 1. What's 1 plus 0? That's equal to 1. What's 1 plus 1? That's usually equal to 2, but we're just gonna write it as 1, okay? That's what we're gonna do in an OR gate. We're just gonna add the values, okay? Don't accidentally write 2 using this logic. You can also remember this as if there's a 1, then the whole statement's gonna be true, okay? So an OR gate can just be used to merge bits, okay? So that's an OR gate. The next thing that you have is an AND gate. Now an AND gate uses a multiplication principle, okay? The AND gate uses a multiplication principle. It looks almost the same as an OR gate, except it's more straightened at the left side, right? Just like that. So it's more straightened at the left side. Now in the case of an AND gate, you have the same things, A, B, X. You have 0, 0. You have 0, 1. You have 1, 0, and then you have a 1, 1. Now in the case of an AND gate, you can think of it as multiplying. So 0 times 0, that's just going to be 0. 0 times 1, that's going to be 0. 1 times 0, that's going to be 0. And 1 times 1, that's just going to be 1. So you can think of it as like kind of like multiplying, right? So you're multiplying the two values, okay? And that's also how you represent this in Boolean logic. We'll get to that in a while. But basically, you can think of an AND gate as if you're multiplying it, okay? So an OR gate, you can think of it as plussing, adding something, and an AND gate, you can think of it as multiplying something, and a NOT gate, you'll think of it as switching bits. Then you have the 3 derived gates. Now the derived gates, they include the NOR gate, the NAND gate, and the XOR gate. So if you pay close attention, you'll notice that these names are very similar to their normal counterparts. So in the case of a NOR gate, all you have is the same thing as an OR gate, except you have this little dot after the gate. This is used to signify a NOR gate, right? In the case of a normal OR gate, it's just that, and in the case of a NOR gate, you just have a dot at the end. Now the NOR gate, or any gate that like starts with an N, which also includes the NAND gate, is just going to be that normal gate, and you just invert the values at the start. So for instance, let me just copy this table. Okay, let me just copy this table, and let me just paste it over here, right? So you have ABX. Now in a normal OR gate, you'd have 0 plus 0, let me just remove these values. In a normal OR gate, you'd have 0 plus 0, and this would be equal to 0. In a NOR gate, you would do the exact same thing, except at the end you will inverse the bit. You will reverse the bit. So a 0 becomes a 1 and a 1 becomes 0. So 0 plus 0 in an OR gate would be 0, but it'll become a 1 in a NOR gate. The N basically stands for not OR. Okay, so you can think of it like that as well. So 0, 1 in an OR gate would be 1, so we take that as a 0. 1 plus 0 would be a 1. We take that as a 0. 1 plus 1 would be a 1. We take that as 0. That's basically a NOR gate. Now, next you have a NAND gate. Now, like the NOR gate, all it is the normal AND gate, except there's a dot at the end. So this looks something like this, and we're just gonna copy the same truth table again. So let me just copy this. So like I said, any of these N not AND or not OR gates, they're the same truth table, except in the end you just invert the values. So 0 times 0 would be 0, but in the case of a NAND gate, it will be 1. 0 times 1 would be 0. We'll just make it a 1, and so forth. That's going to be NOR and NAND. Then you have the XOR gate. Now, the XOR gate is one of the most confusing ones, but I'll just give you a simple statement to remember it. The same statement I used to remember it to this day. If same, then false. It ends up going on your tongue. It's a very catchy phrase. So if same then false, what this means is that for a truth table, like okay, let me just say, okay, so for a truth table with you have A, B, and X, and you have the values. So 0, 0, 0, 1, 1, 0, 1, 1. So in the case of an XOR gate, if same then false, that means that if the value of A and B are the same, then we're going to write the total value as 0. So then you have this as 0, then you have this as 1, this is 1, and this is 0. So if same then false. That's the easiest way to remember the XOR gate. It's a catchy line, you'll catch on to it. Now, besides these, you have logic statements. Now, if there's two things that you need to know. The first thing is called the Boolean logic. The Boolean logic, it looks something like alright. So a Boolean logic will look something like this. Okay, so let me just pull out a hold on, let me just pull out a, where is it? Okay, I think it's this. No, it's not that. I think it's this. Okay, I'll just use this. Okay, so a normal Boolean logic, it would look something like okay, let me just zoom out. So if you have, for instance, a NOT gate and you have the value of A, NOT A would just be a dash on the top. So a dash is used to signify NOT. Alright, now in the case of an OR gate, like I said, it follows a plus principle, so you can write A or B as A plus B. Alright, in the case of an AND gate, you can write A dot B. Right, so dot is used to signify the multiplying principle. Alright, now for the NAND and NOR of these gates, all you have to do is just add dashes, right? So you can just add a dash on A plus B and A dot B to signify the NOR or NAND gates. Now that's basic Boolean logic, and then you of course have the XOR gate. Alright, so these are the basic Boolean logics for these. Right, so besides this, you have Boolean logic statements. So what they are is okay, so there's going to be three kinds of questions that can come. The first type is the ones that we derive from a Boolean circuit. So for instance, you can combine multiple gates. Okay, so like for instance, if you have values like A, B, and C, you can combine these together in the form of multiple gates, like for instance here, right? And you can like bring out the values from the other side, right? So you can combine values like this. The first method is to use it using logical circuits. So in this case, how we would write something like this is to basically you divide the problem up into some parts. So firstly, you would notice that there's a junction right over here. So what I'll write this as is A and B, right? So it's pretty simple so far. It's going to be A and B. Now I'm going to put these in parentheses to signify that it's a junction, okay? And then you have the second gate, so you can just imagine bits flowing through these wires, and then this whole thing goes into an OR gate, which is going to be OR C. So that's basically how logic circuits work, okay? That's how logic circuits work. Now that's the first derivation that you would have. The second derivation is from a truth table. So this is a bit more complicated, okay? This is a bit more complicated. Now, like I said, you can represent logical statements. You can represent, you can represent logical statements using logic circuits. But how would you derive a logical statement from a from a truth table? Let's assume that you have a table like, for instance, you have a table. Let me just bring out a random ass table. Let me bring out a past paper. Actually, we can just copy paste this from past papers. But okay, just a sec. Alright, so let's assume that you have a truth table that looks a bit like this. Okay, so you have the A, right? You have the A, you have the B, you have the C, and you have the X. And let's just say that the values, they look something like this. So let me just write these down for you. 0, 0, 1, 1. So this is a bit more complicated. There were a lot of people from my session who did not know how to do this, and this did come in our exam for like the variant 2, so you guys should know how to do this kind of a question. So then let's just assume that it's going to be 0, 0, 0, 0, 1, 0, 1, 1. Or actually, let's just turn this into a 1, this into a 0, and then this into a 1. So the question is that you need to derive a logical expression from this logical truth table. Okay, so in order to do that, the first step is to isolate the ones. What does that mean? So for instance, what you would do is you would mark a row which has the x value, the output value of 1. Okay, so you would highlight this row, and you would highlight this row, you would highlight this row, and basically you just highlight all these rows. Now you have 4 rows which have the output of 1. Okay, that's the first step. Now the next thing that you're gonna do is you're gonna basically make all of the ones, force all of the ones. How does that work? So you're just gonna take each statement and you're just gonna add an A and B and C. Okay, that's what you're gonna do, and then you're gonna add an OR in between them. Okay, so let me just explain this in a bit. Okay, let me just write this down and I'll go over it and how this works. Okay, and B and C. Okay, so first of all, you write A and B and C for however many rows there are in which the x value is 1. Now the next thing that you would do is you would take either A, B, or C. C if it's a 0, and if it is a 0, then you just write not before it. So like for instance, in this first row, which is this row right over here, we can see that A is a 0. So what I'm going to rewrite this is as not A and B and C. Okay, not A and B and C. Then you have the second row, which is this one right over here. So I can see that B right over here is a 0. So I'll rewrite this as A and not B and C. Then you have the fourth row right over here. So I can see that C is a 0. So I'll rewrite this as A and B and not C. Then you have the last row in which all of them are 1. So we don't need to touch that. And this will be your final truth logical expression. And remember to lie equal to x. Okay, remember to lie equal to x. This is how to derive a logical expression from a truth table. You should know how to do this. The reason that this works is in the end you're essentially just taking all of these values and you're forcing them to become 1s. Okay, you're just forcing them to become 1s, and then you're just adding them up. Okay, I could go behind the sides, but then we'd be stuck here all day. Alright, so that's the second way of deriving logical expressions. The first one was through logic circuits. The second one was through a truth table. Now, the third kind of a logic circuit is one that uses a problem. So, for instance, you have something like this. Okay, so let me just increase this in width. Can I do that? Okay, I can. Okay, so in this scenario, what you gotta do is you gotta look at the statement at the bottom. Okay, so it's basic English. So either turbine speed is less than or equal to 1000 RPM and bearing temperature is greater than 80 degrees centigrade. So what you're gonna do is you're gonna match up the statement to the table. So for instance, turbine speed is less than or equal to 1000 RPM. That is going to be S and 0. So what we're going to do is we're going to write this as not S, which means that we're basically signifying it as a 0. And they said bearing temperature is greater than 80 degrees centigrade. So we're going to write an and, right, because they use the word and we're going to look, bearing temperature is greater than 80. That's just going to be a T. Alright, now the next word they used was an or. Alright, the next word they used was an or. So we're just going to write an or in the center, and then we're going to work on the next statement. So turbine speed is greater than 1000 RPM. That's going to be right over here. So again, turbine speed S greater than 1000 RPM. It's already 1, so we just need to write it as S. And then again, they use the keyword and, so we're going to write and then they use wind velocity is greater than 120 kilometers per hour, which we can see is already a 1, so we're just going to write it as a W. Okay, now the next thing, keyword is also an or. So now let's go on to the final statement, which is going to be bearing temperature is less than or equal to 80 degrees centigrade. So bearing temperature less than or equal to 80 degrees centigrade, that's going to be not T. So we're going to write this as not T. And then again, the keyword they use is an and then wind velocity is greater than 120 kilometers per hour, which is already going to be a W. And again, don't forget, you need to write the output variable that is going to be given in the question. So for instance, in this question they mentioned that it is the output X. Okay, so that is how you use you derive it from the from the problem styled question. So this is how you derive logical truth tables. We're gonna go into techniques on how to solve these things when we do the past papers, but yes, let's just write it over here as well. So you use X is equal to A plus B, X is equal to A dot B. But yes, that basically sums up all of chapter 10. It's just that. Okay, it's that easy. So do you guys have any questions, anything whatsoever? Let's just go over one last thing, and that is how to actually work with truth table, how to actually work with logical circuits. So for instance, if you have a logical circuit such as A, B, and C, and you have a bunch of logic gates passing through it, right, like this, right, so the easiest technique to use for this, I'll tell you guys the easiest technique to use for this as well. Okay, let me just bring this over here. So for instance, this is a logic circuit, right? Now the easiest technique to use for this is to make additional letters. So after ABC, you can say that this is gonna be D, this is gonna be E, this is gonna be F, and this is gonna be X. So you can use these different letters as placeholders, and you can calculate the value of each one of the letters through that way. And we'll get to this when we do past papers, but yeah, that basically sums up all of it. You should obviously go in junction, so you would complete this part first, and then you move on to this part, and then you do this part, and then you would do the whole entire circuit. That is basically logic gates. Any question from chapter 8 whatsoever? Sorry, chapter 10. Apologies. Any question from chapter 10 whatsoever? Okay, let's just work with some definitions. So the only definition you should know is what a truth table is, right? So you should know that a truth table, let me just write it down as well. So you should know that the definition of a truth table is that it's a method of checking the output from a logic circuit or a logical expression, right? So that's the technical definition for it. Now that basically sums up chapter 10. Do you know where to find some practice how to do Boolean expressions? Just do past papers. Just do past papers, right? Can you show the types questions where they give you examples? We just covered them. The strategy to do these kinds of questions, like the one here, this is like one of them, right? So the strategy to do these kinds of questions is to just look at the English. Okay, so for instance, right over here, they wrote either turbine speed is less than equal to 1000 rpm. So you basically take this keyword and you match it with the table. So where is turbine speed is less than 1000 rpm? That is right over here. So the binary value is 0. So you basically want to turn this 0 into a 1. How would you turn a 0 into a 1? You would add a not before it, right? Now, what is the parameter? What is the letter of this entire thing? That's S. So we wrote not S. Alright, then they said and. So we're going to write and in the between, okay? So the best way to go about these is to use English, right? So and then the next one was bearing temperatures greater than 80 degrees centigrade. So we're just going to use T, so not S and T, right? Now the next keyword they used was an or, so we're just going to write or, okay? And then we're going to do the second condition, which was turbine speed is greater than 1000 rpm. Again, match this in the table. You'll see that it is basically equal to S. So S and W, right? So again, they use the word and. Wind velocity is greater than 120. So right over here, you can see that it's W and it's already 1, so we don't need to touch that. And then lastly, the last statement was also an or, so we just wrote an or. And then you write bearing temperature is less than equal to 80 degrees. So bearing temperature is less than equal to 80 degrees right over there. So since it's 0, we need to turn that 0 into a 1. So we're just going to do not T and, again they use the keyword and, wind velocity is greater than 120. So we're just going to do not T and W, and we're going to make this whole expression equal to X. Alright, that's how you do the table kind of questions. Alright, so any other questions besides this, or should we move on to chapter 9, which is databases? Okay, let's move on to chapter 9. Chapter 10 is really simple. All you need to do is to do practice. So chapter 9, databases. So when we talk about databases, okay, so we know that each data can be stored in a collection. Okay, we call this collection a database, or the technical definition of a database is that it's a well-organized compilation of data. So a database is basically a well-organized compilation of data. So you basically you can say that it's used to retrieve information. Okay, so you can say that it's used to retrieve information. So it's basically you basically have a big ass table and it has a bunch of values in it, and you just use a database to store these values and to get these values, right? So you should know why we need a database. So obviously when you have like a lot of people, for instance, or you have a lot of things to store, that's when you use a database. Okay, you have a lot of objects to store and you want to be able to fetch them instantaneously, you'd use a database to store all of them, right? So there's a few reasons, right, that you should know for your exam. So reasons to use a database. So the first one, like I said, is that you get to store information about people, events, or objects, etc. Right? So for instance, you can say everybody in this VC. If I wanted to make a database of everybody in this VC, I would get your all's username, I would get your all's name and your all's PFPs maybe, and I'd store that in a database, right? So you can just use a database to store information like that. The second reason is that modifications need to be made once. What does that mean? So let's just say one of you all changes their display name. That means that all I need to do is to update that in the database once. Okay, so this leads to data consistency, right? So that just means that data is consistent throughout. It doesn't get jumbled up. Okay, and so on and so forth. Someone tagged me and he's on pseudocode. We're not gonna do pseudocode today. We're gonna do pseudocode tomorrow. Okay, we're gonna do pseudocode tomorrow. Then you have okay, so you have little no data duplication. No data duplication. What this means is that if you have one user inside of a database, then it's just going to be that one user. You can't duplicate data. You can't have multiple data or multiple users with the same username. We're going to talk about this in a while as well. So you should know what tables are. Okay, so you should know that in a database, data is stored in tables. So what that looks like is, for instance, let me just insert a table right over here. So let's just say that I have a database of everybody in this call. So I have their username, their display name, how long they've survived, how long duration, right? Duration of them being in the VC. So for instance, I can say that myself, Ateeb Sohail, the display name Ateeb Sohail, and I've been in this VC for 30 minutes or 40 minutes, something, right? I can say another user. I can add another user, like so there's Halo in this thing. Okay, so I can write Halo, right? So Halo dot Genation, right? And I can say that his display name is Halo and he's been here for 30 minutes, and this goes on and on and on. Okay, so like there's other people. I can write for instance Avana, so I can write Ayat, royalty, wait, and she's been in this VC for 20 minutes, and so forth. So it's basically a collection of data, right? So I can just go on and on and on and write about every single one of you lads, and that's basically what a database is. And now this whole thing, it's called a table. Okay, so data is stored in tables. Now each one of these things, each one of these rows is called a record. Okay, so each row is called a record. So this row right over here, comprising of my name, display name, and duration, this is a record. All right, this is also a record, and so forth. Right. So then you need to know what fields are. The username, it's a field. The display name, it's a field. Duration is a field. Let's just say I wanted to add age as well. So I'd go age, and then this is also a new field. So I'd go like something like 45 years old, 12 years old, I don't know, like 18 years old. So it's basically fields. Okay, so these are fields. Okay, they're fields. So you should try out Microsoft Access. Alright, that's a software we use for database management, though I think it's a bit too late to do that, but that's basically, in our syllabus we just use Microsoft Access. We refer to Microsoft Access a lot. Now we have validation. Okay, so the thing that we use to enter this data, it's called a database management software, or DBMS. You'll go into this more in AS level, and in the DBMS you have validation, right? Which basically means okay, so it basically means that during construction, data validation checks are set by the developer. So for instance, I have a display name, or actually let's just go with username. So I can add a check. I know that in usernames it can't be something like it can't be something that has a capital letter. I just realized that this is very wrong, but I can like have a validation check that says that it can't be a capital letter, it can't have spaces. So these are all validation checks, right? We're going to learn about this a bit more in chapter 7 as well, but these are all validation checks. Now each one of these values right over here, they can also be categorized down into data types. So these data types in databases are text or alphanumeric. So text slash alphanumeric. What this is something like Ateeb Sohail, right? So it has text, or it can also have numbers. So it's a basic string. Okay. The next thing is a character, right? So a character, something like a. Okay. The next one is boolean, so something like true or false, right? So let's just add a boolean here as well. Is alive, right? So false, true, true. So that's boolean. Then you also have real, right? Real, which is basically a number that goes into decimal, so like 10.04. Let's add that here as well. Let's call it level. Alright, so let's just give myself 99.34, 20.230, 20.33, and 2.22. So that's what we call a real. Okay. Now then you have a date slash time. Okay, date slash time. So these are the data types that you have in databases. Now the next thing that you should know is what a primary key is. Okay, so a primary key is a field that's used to uniquely identify a record. It's unique and cannot be duplicated by any other record. So in the case of Discord, if you try to change your username to something like mine, right? So if you try to change your username to Ateeb Sohail, it'll give you an error that a user like this exists. A user with that username already exists, right? So that's basically what a primary key is. So in our case, primary key would be something like the username. So it's unique. Okay, it can be used to uniquely identify a record, right? So for instance, if I wanted to fetch this entire record, I could say that I can fetch this entire record by just looking for Ateeb Sohail, right? So I'll just say that the username is the primary key. The username cannot, the primary key cannot be duplicated. Okay, there can't be another Ateeb Sohail, and there can't be another halo.generation, or there can't be another royalty with, and all of this. Yeah, so there can't be duplicates of the primary key. So the marking scheme definition, you'd write a field that's used to uniquely identify a record, and yeah, that's basically a primary key. So yeah, that's basically what primary key is. The next thing is SQL. So any questions so far about all of this? Any questions so far? Before we move on to SQL. Bro, is this the whole syllabus? We're going to try to do the whole syllabus today and tomorrow. When is trace tables? That's going to be chapter 7, so after this chapter. Alright, so before we move on to SQL, let's add a bit more data to our table. So we're just going to use this table that I made on top, and let's just add a bit more fields to it. So let's just add something like city, and we can say like Peshawar, Larachi. We can say something like planet, Earth, Mars. What the hell, Mars. Okay, I can add more usernames. So let me just fetch random people's usernames. Okay. Okie Flakes. Okay, Okie Flakes. Verb. And I'll say 20 minutes as well. So age, let's just write that as 18 as well. Is alive, false. Minus, or actually let's just change this to 100.2. City, let's write this as Karachi, and planet, let's slice this as Jupiter. So let's just add one more user so that we have like a bit of consistency when we're practicing SQL. So let's just add anybody from here. So okay, let's just go with you. CUSFYT, 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 let's just say you've been in this VC for 0, 0, right? Let's just say that your age is like 105. Let's say you're true, your level is 100.2 as well, and your city is Islamabad, your planet is also Earth. Okay, so we have this small table, and let's work a bit with SQL. So what SQL is, we call it SQL, you call it SQL. Okay, you can also pronounce it as SQL. It basically stands for Structured Query Language. So the name obviously suggests that it uses something that we call to search queries. Okay, so we learned how to fetch data from a table using queries. So in the IGCSE syllabus, we have a few. Let me just pull out the IGCSE syllabus on my right as well. Hold on a sec. So in the IGCSE syllabus, we have a few SQL statements, okay, SQL queries. So these are the select, right? Select, the from, where, order by. I believe. Let me just confirm. I'm unsure because the syllabus changed in regards to these a bit. So let me just confirm. Okay. Okay. Select, from, where, order by, sum and count. Sum and count. Now the question is going to ask you to write an SQL query. Okay. So the basic SQL query, the thing that's going to be universal for all of them, is the two statements which are, let me just write universal for all queries. The two statements which are select and the from statement. So let's go over this. Let's say that this table is called table name, and let's call this CS sesh. Okay, let's just call this. Okay, so the select thing is used to select fields. Okay, so I'll also write this over here, fields, right? The from is used to select the table name. Okay, so for instance, let's just say that I want to select the username field. Okay, I want to fetch the username field. So I would do something like select username, and the table name is CS sesh, right? So I'll do CS sesh from CS sesh. So these are just universal queries. Okay, now if I were to run this query right now, what it'll do is it'll just fetch me this entire table right over here, just the username. Let's say that I also want to fetch the city. What I would do is I would do select username comma city. Now what this will do is that it'll show me all the usernames along with their respective cities. I can also say something like select star or an asterisk, right? So what this does is that it'll fetch me all of the fields. Okay, it'll fetch me all of the fields. Okay, now that's basically what select and from are. There's always going to be a select and from in each one of these SQL queries. Okay, now the next thing is the where thing, where condition. Now the where thing is mostly used to specify a condition. Let's say that I want to fetch all of the users who live in Larachi. So I would do something like where city is equal to Larachi. Okay, now let's say that I want to fetch all the fields, select star, right? So select star from CSS where the city is equal to Larachi. What this will do is it'll fetch me all the users and all of their fields, which is just going to be halo.generation and ayat, right? So this is going to be these two people, and it'll basically fetch me this purple thing that I've highlighted. Okay, it'll just fetch me this purple thing that I've highlighted. So that's basically what it's going to do. Okay, that's what a condition is. Now let's just say that I want to fetch a specific user, for instance. Let's just say that I want to fetch royalty wit. So I could do something like where username is equal to royalty wit, right? So that's another way to fetch one of these. So then there's other conditions, like for instance, let's say I want to fetch all the users where they're alive, right? So I can do something like where is alive is equal to true. Okay, that's for Boolean. Okay, then you have the collective thingies. Okay, so like for instance, you have something like you want to fetch all the users who are between the ages of 10 to 20. So I would do something like age is greater than or equal to 10 and age is less than or equal to 20. So that's another way to do this, right? So that's another way to specify a condition. Let me just okay. All right, so that's another way to specify these conditions. So then what you have is the next statement, which is order by. Okay, order by. Okay, let me just make this a less than sign. Let me just remove this. Okay, let's just say I want to fetch all the users whose age is greater than like 20. Okay, so the next thing is the order by statement. Now order by statement is basically used to what do you say, is used to um, order the sequence in which the queries come. So like for instance, if I were to do order by ascending and I were to select all of the fields and all of the records, and I selected like for instance a username field, what it'll do is it'll first show me Ateeb Sohail because it starts in A, and then it'll show me CUSFYT because it starts with C and that selects the alphabet. So that's basically what order by ascending means. It means going from the smallest to the largest. If I were to do this with a numerical field, it would go something like it'll show the 12-year-old first, then the 18-year-old, then the 18-year-old, then the 45-year-old, and then the 105-year-old. Same goes for the float values, and same goes for any other string value or a date/time value. It basically does it that way. Okay, so there's order by ascending or there's order by descending. Okay, so there's ascending slash descending. Okay, so there's two types of order bys. Now the next thing is mainly used with the select field. Okay, the next thing is mainly used with the select field. So let's say that I want to fetch the sum of all of the levels of everybody. So I would do select sum level from CSS, and I would remove both of these fields, right? Because I'm just selecting the sum. So what this will do is it'll take all of these levels and it'll add them together. Okay, now let's say I want to fetch the sum of all of the levels which are greater than, let's just say 30, right? So I would do something like select some level where level is greater than 30. Okay, what this will do is it'll fetch this one, and this one, right? It'll fetch this one and this one, and it'll just add these values together and it'll return it. Okay, so sum field. Okay, so it'll just be a sum of field. It'll return sum of field. Okay, then what do you say? Then lastly you have the count again, which uses the field thing. So let's just say that I wanted to count the number of fields or the number of records which have the is alive flag as true. So I would do select count is alive, or let's just say select count username, or you can actually just do is alive. It's your own choice. So from CSS where is alive is equal to true. So what this will do is it'll find all of the values where is alive is equal to true. So there's one right over here, there's one right over here, and there's one right over here. It'll count them. So in this case there's 3, and it'll just return the value of 3. Okay, that's how SQL works, and basically that's it for SQL. The next thing you need to know is in these conditions there's a few operators that we use. So operators, let's just talk about these operators and then we'll close chapter 9 as well. So okay, let me just okay, so these operators, they look something like okay, so these operators, there's the equal to operator, there's the greater, I'll put these in a numbered list as well. There's the equal to operator, there's the greater than, there's the less than, there's the greater or equal than, there's the less than equal than, then there's the not equal to, right? There's not equal to, then there's between, like I don't think you should use these, right? So you should just use and, or, and not, right? So these are the basic operators. Okay, these are the basic operators. So basically that pretty much sums up chapter 9 as well. Is there any questions from this chapter? SQL, databases, anything? Oh, one more thing. All SQL queries end in a semicolon. Remember that. SQL queries end in a semicolon. Okay, so you should remember to add semicolons to the end of the statements. How to use between and like. I'm unsure if it's in the syllabus. Let me just see. I don't suggest. Yeah, no, it. I don't think it is in the syllabus. So just okay. I'll just remove that. Don't worry about between and like. Just use and or not. Okay. Can we say like in stock is equal to nest? No, no, no. Okay, no. We'll get this in the past papers as well. We're gonna get this into the past papers as well, but you can't do that. You have to specify yes or no. If they have, or we is it more safe to say in stock is equal to yes? You would add the commas with it. Yeah, sorry, the what do you call it? The quotation marks with it. Okay, we're gonna get into this more when we get to the past papers, but yes, okay. My CS sir said it doesn't matter. You can listen to him, or you can trust the marketing scheme. It's your own choice. Right. So that's basically almost about it. Let me just fix up these notes real quick. Get rid of this red because it's really triggering my OCD. And just write down your questions. I'll get to them in a sec. Let me just fix this so my OCD doesn't kill me before the session does. Okay. Okay. All right. Okay. There we go. So, any questions? Display name. Okay, so first of all, you should do order by ascending. Okay, so you should write the full thing, order by ascending, not just order by ASC. Okay, you should not use this order by ASC. They specifically said that in the. I remember reading that in the 2024 syllabus change. So you should use order by ascending, right? So don't just use ASC. Isn't it descending by default? It's better to you write the whole thing. Okay, it's better to write the whole thing. So let's take a 5 minute breather right over here. I need to go pray Maghrib Salat as well. But yeah, can we do it in alphabetical order? Yes, you can do that in alphabetical order. And okay, so the order by statement, I see some confusing. Um, listen, all you have to do in the order by statement is specify ascending or descending. Okay, you don't need to write any field name. You basically select the field name and you sort it that way. Okay, you don't need to necessarily write it. Okay, and we're gonna cover this in the past papers as well. So don't worry yet. Okay, don't worry about it yet. Okay, so yeah, that's basically it for chapter 9, and this is taking like a 5 minute break, and we'll be back in like 5 minutes to do chapter 7. Okay. In chapter 7, like I said, we're not going to do any theory part, any logic part today. So no flow charts, no structure diagrams, just the theory part. The reason I had today's session, I was planning to do all of P2 tomorrow in one go, but the reason I had today's session was to get these annoying theory related topics out of the way, the small ones like Boolean logic, databases, and the theoretical parts of chapter 7 like the program development life cycle. So yeah, we're just gonna do theory today. It's not gonna be, we're gonna be done within like the next 20 minutes. So today is probably just gonna be like a 1 hour, half hour, 1.5 hour long session. So it's not that big, just a session to get rid of the ones that we don't need, right? To get rid of the stupid, annoying, small, mini, weird topics that are stuck in the center. Okay, so I keep seeing some questions regarding SQL. So yes, you have to write SQL in you have to write SQL capitalized, and you should use the whole word. You should use ascending, or actually, I'll just show you guys the syllabus. Okay, since a lot of you just need to see the syllabus. So this syllabus order by. Alright, so just go open any marking scheme and you'll see that it uses ascending or descending. You can write ASC, you can write DESC, you can write ascending, you can write descending, so don't need to worry about that a lot. Okay, so you by default for up to the 2026 syllabus, yes, it is ascending by default. But after 2026, 2027 onwards, I believe, you have to specify if it's ascending, right? So you can see that in the syllabus change as well. Sorry, after 2026 onwards, not 2027, 2026 onwards. Okay, so that is okay. That's chapter 9 covered. So let's move on to the theory part of chapter 7. So we're gonna be done with that within like the next 20 minutes, which is also when we'll conclude the session. So not a big session, like I told you guys. I just want to get rid of the weird logical part. So it's just going to be program development life cycle that we're going to talk about. We're going to do all of structure diagrams, pseudocode flow charts, all of that stuff. We're going to do that tomorrow. Okay, we're not going to cover Python. That's way too extensive. So yeah, let's just talk about program development life cycle, and we're going to be done with that in like 10-15 minutes, and then we'll conclude today's session. Right, so chapter 7, algorithm design and problem solving. Chapter 7, algorithm design and problem solving. So the first part of the chapter 7 is called the program development life cycle. Now, if you're a software developer, if you're somebody who's making any application, any sort of computer application, you're going to follow a thing that we call program development life cycle. What this is that you have 5 basic steps. These are the analysis, the design, coding, testing, maintenance. So what this means is that if I'm, for instance, creating a Discord app, right? If I'm creating Discord, for instance, firstly, I would analyze what parts of Discord I need, like the chats, the voice channels, all of this. I would write this down somewhere. Okay, that's the analysis part. I would analyze what features need to be implemented. Okay, that's what analysis stage is. Then you'd have the design thing. Now this is going to use something like flowcharts, structure diagrams, pseudocode, or even UI, right? User interface. This is basically the design stage. I would design something. The coding stage would be me actually writing code in Python, for instance, to implement the application itself. Testing would be me finding other people who would end up testing the app. So they'd go into voice channels, they'd type text and whatnot, all of that, and they would basically they basically test the program that I created. Last stage would be maintenance. Now after I've created the app and I've published it, obviously it's not going to stay perfect forever. I need to keep up to date with changes. I need to keep up to date with different things that is going on, different bugs that end up popping. So we have to keep up to date with that, and that's where maintenance comes into hand. Okay, so let's talk a bit about this more in depth. So in the analysis stage, we okay. So let me just okay. In in this stage, we okay. Let me just okay. In this stage, we define the problem clearly. Okay. Uh, Also known as requirements for the program. I'll get into this in a while. Let me just write this down. Uh, Uses tools like abstraction and decomposition. So the analysis stage is, like I said, we basically have a giant problem. And we basically break down that problem, or we look more into that problem. We analyze that problem. Okay, and we use a few tools for this. Now, these tools are abstraction and decomposition. Abstraction basically means oops, my bad. Abstraction basically means to what do you say? It basically means to focus on the essential elements of the problem, or basically taking out unnecessary details, right? So for instance, if I have a problem like I want to make a text channel named community events, all right, that has like the ability to send text. Okay, I'd remove all the useless information from that prompt. That's basically abstraction, focusing on the necessary information and removing any unnecessary information. Okay, that's basically the abstraction part. Now decomposition basically means to break down the problem into further sub problems. So if I have a large task like creating a weather app, I could break that down into two smaller tasks, like for instance fetching the weather or fetching the location. And I can break that down into further smaller tasks like verifying the weather or verifying the location or getting the time, and so on and so forth. So you can break down problems into sub problems, and this is what decomposition is. It's basically breaking down problems into smaller, more manageable parts. So if you want to write down like the complex definition, you can say breaking down complex problems into smaller, manageable parts. That's basically what the decomposition state is. Alright, so that's basically what analysis is. That's everything about that you need to know about analysis. Now, the next thing is the design stage. Okay, in this stage, the programmer, right, the guy who's developing the programmer analyzes the tools or the tasks to be completed, right? And it basically comes up with documentation in the form of, for instance, flowchart, structure diagram, and pseudocode. So, for instance, if I were to create, what do you say? How long is today's session? Just like 10 more minutes. It's literally just a program development lifecycle, and then we're done. So we're gonna have the remaining done tomorrow. The main parts we're gonna do those tomorrow. So just 10 minutes.
Sorry, I can't help.
Fucking Siri. All right. So, right. So in the design stage, we have the programmer who analyzes the entire problem. Okay, and he documents the problem, right? So for instance, if I want to create an algorithm that basically fetches the weather, I could make this algorithm in pseudocode or in flowchart, and I can then just use that to implement it in the coding stage. So it basically means to get a deeper in-depth look at the problem in the form of something that isn't the program itself. So it's obviously easier to write pseudocode as compared to actual program code of implementing the project. That's basically what the design stage is. Then you have the coding stage. Okay, now the coding stage is basically writing each module of the program. Okay, that's what the coding stage is. Okay, so in a suitable programming language. So, for instance, you created a design in the design stage, and now you're just gonna implement it in the coding stage using a programming language like Python, Java, C++, whatever you want to use. That's basically what the coding stage is. Okay. Then you have the testing or the iterative testing phase. In this stage, what we're doing is we're testing, testing different modules to make sure they work correctly. Okay, that's what the testing stage is. Okay, now one thing that you should know is what iterative testing is. So this comes in there, the coding part as well. So iterative testing, what this means is it basically means to conduct tests, make code changes, conduct tests, make code changes. Don't worry if this seems a bit too theoretical. I'll get into a real life example of this as well. It basically means to conduct tests, make changes to the code, and repeat the tests, make code changes, and repeat tests till proper functionality. Alright, so that's what iterative testing is. Okay, we're gonna get into this in a while as well. Okay, now in the testing stage, you can use test data to see how the program reacts to different values. Right, so that's basically the program development lifecycle. Let's take an actual example. Let's take an example of something that's really simple. Let's take ChatGPT for example. The program development cycle for ChatGPT. How would that look like? The first stage would be the analysis stage. We would analyze how we want to create ChatGPT. Now, when we think of ChatGPT, what do we have? We have ChatGPT. We want to make a user interface. We want to add an input, an output, all of this. All right. So that's going to be the analysis stage. We'd also work with abstraction. So I'd get rid of the useless information from the entire project details. So I'd write down the project details. I'd be like, okay, we need to create a chatbot and blah 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 blah. Abstraction would mean that I remove the stupid text that we don't need, and decomposition would be that I break down it into smaller problems. Like for instance, if I talk about ChatGPT, I can break down ChatGPT into the user interface and the AI chatbot itself, then the API and all of these different things. I can break it down into the different things. That's decomposition. Then there's design. In the design stage, I would make a UI of the interface, right? I could maybe make a flow chart that sees how the chatbot responds. I can make like a structure diagram, or I can write pseudocode to see how the chatbot responds to different inputs, right? That's basically the design stage. The coding stage would be the actual time where I sit down, I open my laptop, and I start coding the chatbot itself. That's the coding stage. Then the testing stage would be something like I get a lot of you guys, and I'd be like, hey, listen, I made this chatbot. I want you guys to test it. And you guys would, what do you say? You guys would go to the chatbot and you would enter in random values, see how the chatbot responds, and you'd come back to me and give me my feedback. The last stage would be maintenance. I'd basically publish ChatGPT, and I would be like, and I would keep it maintained. I'll make sure that there are no bugs. And with that, we can conclude today's session. Nothing, I don't want to do anything that's non-theory related today. So that's basically all we're going to do today. The remaining stuff, which is going to be structure diagrams, pseudocode, flowcharts, testing, trace tables, algorithms, validation, verification, all of this, file handling, you have programming concepts, maintainable programming languages, arrays, all of this. We're going to do that tomorrow. Okay, right, I'm going to try to start it at the same time I started today, maybe a bit earlier, an hour or two earlier, and I'll upload the recording. I'll upload the recording right now. So don't worry about the recording. I'll upload it right now. You can see there's a pin in the channel, okay, in our IGCSE Computer Science channel. You'll see it's a pin from me. And with that, we can conclude today's session. It was a small one. I just wanted to get a brief introduction. I just wanted to get you guys started on P2. And tomorrow we're going to get into the actual tough part of P2. We're going to approach pseudocode. In a way that we're gonna approach pseudocode in a way that we don't actually learn from the book, but rather we're learning a programming language. Okay, so we're gonna approach pseudocode like that. All right, so that's gonna be it for today. If you guys have any questions, let me know. Yeah, I'm listening to you guys' questions. When's the next session? Tomorrow, around the same time as today, maybe a bit earlier. Can you explain bubble sort? I'll explain that tomorrow. Uh, don't worry. I just wanted to get the theory part, the boring parts of B2 out today. All right. So yeah, I guess I'll just stop recording. So it was a small session. We just lost like